pleasant good day. My name is Neil Ragbir, student of University of the West Indies, Department of Mechanical Engineering, and I am here to present the preliminary report for my final year project. The title of this study is the thermodynamic design and optimization of a mechanical vapor compression refrigeration inlet air cooling system for a gas turbine on a combined cycle in Trinidad. Now the question arises, what inspires a student to conduct this research? With the country being more industrialized, the demand for energy is on the rise. The losses that the gas turbine suffers due to the ambient temperature poses a hindrance in this upward growth. Hence, the problem needs to be addressed. By applying inlet air cooling, it allows the gas turbine to achieve close to its maximum design performance. And finally, as a final year student eager to enter the world of work in the industry as an engineering graduate, I would like to be equipped with the knowledge of the field as well as appreciate the significance of these power plants. What is the combined cycle power plant? It uses both the gas and steam turbine to produce up to 50% more electricity from the same fuel than a traditional simple cycle plant. The waste heat from the gas turbine is routed to the nearby steam turbine, which generates the extra power. The role of a combined cycle in a country is crucial as it is responsible for almost 1/3 of the nation's power supply. The components on the combined cycle power plant are the gas turbine, the heat recovery steam generator, also known as the HRSG, the steam turbine, and the generator. The gas turbine uses air as its working fluid and burns fuel in the combustion chamber to generate the steam, and this force is used to turn the turbine connected to the generator. The role of the HRSG removes exhaust heat from the gas turbine and uses water to convert it to a superheated steam to drive the steam turbine. This driving force from the HRSG connected to the generator creates an additional power output. Inlet air cooling is a method used to cool the air coming into the gas turbine, which is at ambient temperature. Methods of cooling stems from evaporative, absorption, and vapor compression, which is the method chosen for this study. The inlet air needs to be cooled to the required ISO conditions of 15 degrees Celsius, which in turn will benefit the cycle's efficiency and generate more power output. By grasping the general concept of the study, the problem statement says what configuration of the mechanical vapor compression refrigeration cycle along with a chilled water system and heat exchanger will be most suitable to achieve inlet air cooling for a gas turbine on a combined cycle plant. The aim is to design and optimize a mechanical vapor compression system for inlet air cooling on the gas turbine in a combined cycle plant using thermodynamic principles. Hence, the components to be designed and optimized are the mechanical vapor compression cycle to be adapted to the gas turbine, along with the heat exchanger and the chilled water system to obtain maximum inlet air cooling. The proposed study methodology for this project are as follows. To calculate the current efficiency of the combined cycle operating at ambient temperature, to apply the correction curves and calculate the expected theoretical output values when inlet air cooling is obtained, to account and calculate for the greatest steam generation after applying inlet air cooling by applying heat balance calculations to sections of the HRSG. The new gross and net power of the cycle will need to be calculated to account for the new exhaust flow temperature. To design and optimize the mechanical vapor compression system to be incorporated into the inlet of the gas turbine. Along with the MVCR cycle, a method needs to be designed to use a chill water system and a heat exchanger into the MVCR cycle. Design and optimize a method to use the steam generated to drive a turbine to generate power to the mechanical vapor compression refrigeration cycle. Hence, in doing so, the design and calculations need to be done to find out the required compressor power to drive the MVCR cycle based on the heat load of the turbine. Primarily, research papers, articles, and textbooks were used for literature in this study thus far. They aided in the overview of the combined cycle power plants and its different components and how they each play a role in generating power output to the country. Studies have shown the negative effects that ambient air temperature has on the gas turbine performance. It can be said that the gas turbine's output is inversely proportional to the ambient temperature. Additionally, research has also shown how inlet air cooling can help the effect of the ambient temperature on the gas turbine by reducing its temperature from an average of 27 degrees Celsius to the required ISO condition of 15 degrees Celsius to obtain its desired performance. And lastly, an understanding of the mechanical vapor compression refrigeration system and how it can be adapted to the workings of the gas turbine on a combined cycle plant was understood. In conclusion, the expected outcomes and contributions for this study are to improve the cycle's efficiency by incorporating inlet air cooling, to obtain the specified design performance of the gas turbine, and to generate a greater power output. Thank you for your time, and I look forward to answering any questions that you may have to the best of my ability.